All right, here we go, the triangle midsegment. This should be relatively quick and painless, and I think you guys will take to this and the properties of the triangle midsegment quite well. So the midsegment of a triangle is just a segment that joins two midpoints, joins the midpoints of two sides of the triangle. So every triangle has three midsegments, and they would in turn form the midsegment triangle. So take the midpoint of each of these sides, boom, boom, and boom, and you connect those and you'll have three midsegments and they form a midsegment triangle. So the midsegments in this case are segment XY, segment YZ, and segment ZX. And the midsegment triangle would therefore be triangle XYZ. As far as using this, you can certainly jump into the coordinate world, and oftentimes ends up being a nice way to work through this. Now, if we take a random triangle, RST, and we have points at -7, 0, -3, 6, and 9, 2. 9, 2. Right? And if we were to join those together, we have this triangle that's formed with those 3 points. And if M is the midpoint of RT, I suppose we should label the point. So this was point R, and this was point S, and this is point T. M is the midpoint of RT, so wherever that happens to be, that's M. And N is the midpoint of ST, wherever that happens to be. So those obviously aren't in the right place. I just threw those up there. But we're going to try to show that MN is parallel to RS, and that MN is also 1/2 the length of ST. So I'm not going to go through all of this math because it's fairly straightforward, but you need to know the distance formula. You need to know the midpoint formula, and with those two things in mind, and then also the idea of slope, if we look at, so the slope of segment RS, for instance, it's just the change in y over the change in x. So it's delta y over delta x, and you come up with that slope. So we have, if we have R and S, we end up with 6 over 4, which is 3/2. I did that right, just going through that quickly. So then you want to check the slope of MN. Well, it's a problem because we don't know the coordinate of M and the coordinate of N, so use the midpoint formula for R and T and work that out as well. Right? So we need to know the coordinates of M and the coordinates of N. So you should be able to figure that out, work through it. Again, it's just the midpoint formula. If you don't remember that for some reason, shame on you, but you can very quickly and easily go back and look that up. But that's kind of how you would work through that. So you have the slope of one, compare it to the slope of the other, and then for the 1/2 the measure, you need the distance formula, you need the midpoint formula. But coordinate proof, sort of sketch or coordinate work through works quite well on a problem like this. So you will find that after you show that last one, if you did work through that the midsegment of a triangle is parallel to a side of the triangle, and it's 1/2 the length of that side. So anytime you join two midpoints of a triangle, so you make a midsegment, it's going to be 1/2 the measure of the side that it's parallel to. So it's going to not only be parallel, but also going to be 1/2 the measure. So we look at this breakdown, we have some mid-segments drawn, and we can find each of these measures. So for the measure of JL, remember JL, when there's no markings over it, means the length of. So we're trying to find the length of JL. We're trying to find this length right here. And we knew that PN is 36, so JL has to be twice that, or 72. If we want to know the measure or the length of PM, so we're trying to find this one. We know that the length of LK is 97, so it has to be half of that. So 48.5. And then we can also look to figure out the measure of angle MLK. So MLK, which would be this angle measure. Well, if PM is a midsegment, and it is, then these would have to be the same measure, because they, with parallel lines, they would be corresponding angles. I know you guys love corresponding angles, or at least the word corresponding, right, Ben? So 102 has to be in both of those spots. Therefore, the measure of angle MLK is 102 degrees. So really, that's most of what you need to know about triangle midsegments. You can also use this for some indirect measurement application. This is right from the book, and there's not a whole lot to it, but it's kind of a cool thing. You know, Anna was trying to find the distance across the base of this volcano, and she can't really, there's no nice way to do a direct measurement, measuring from A to E, because you'd be going up and over, and digging a tunnel is not very practical. So, but using this whole idea of a midsegment, starting at point C, she measures down to point A, and the same thing, she has a line of sight to these spots, and measures to point E, and do that midpoint, this midpoint. She can then figure out the distance from A to E going across. So using those, you figure out that if you just measure from B to D, you know that that's going to be 1/2 the length of AE. So very quick, easy way to do an indirect measurement to come up with the distance across this particular volcano. So that's it for today, and we'll see you next time.